There's no simple definition of what a confined space is. Sewers, closed tanks, tunnels, these are obvious. But the term confined space can also be applied to open-top tanks and vats, furnaces or ditches and channels, anywhere in fact where access is difficult and the breathing air is potentially unsatisfactory. Large or small, open or closed, they all have one thing in common: they can kill. And sadly, many of these incidents result in multiple fatalities. Too often the rescuers of the original victim enter the confined space on impulse without taking the proper safety precautions and themselves become victims. Entering a confined space should always be a well thought out, methodical process where all the potential hazards have been considered and steps taken to overcome them. Toxic gas or vapours can come from residual material known to have been in the tank or leak in from a connected system if the space hasn't been properly isolated. Fires or explosions can result if the risks posed by the presence of flammable gases, liquids or solids are not carefully considered. Many gases, both flammable and toxic, are heavier than air and can remain at the bottom of a tank. Oxygen deficiency can occur through chemical processes when a metal container has been sealed for an extended period or when there is inadequate ventilation during the work. Injuries resulting from direct contact with extreme heat or cold and dermatitis-producing chemicals can be avoided by the proper use of protective clothing. Ideally, though, these hazards should be removed from the confined space before work begins. A special danger lies in moving mechanical parts within the confined space. Stirrers, mixers and conveyors can cause serious injury if they are accidentally activated. Burial of an individual beneath solids is a risk, particularly where silos are concerned. These are just some of the hazards to look out for when considering working in a confined space. It's important to remember that each confined space presents risks that are uniquely its own. To deal with this, a system has been devised where a well-planned procedure for entering and working in each confined space has been set out in a permit to work document. This document lists the work to be done, the precautions necessary, and the sequence of actions which will make the job safe. Its successful application depends entirely upon the workers conscientiously carrying out its directions, each and every time there is entry to a confined space. Once the entry procedures have been successfully completed, an authorised person who has been extensively trained and tested will issue a certificate for entry to the confined space. The certificate for entry can be part of the permit to work or can be a separate form. Regardless of this, the procedures detailed in a permit to work must accommodate any changes made to the space concerned and be reviewed regularly to include advances in health and safety practices. The permit to work document is designed from a sort of checklist which considers all the factors affecting confined space safety. They're all critically important because in a confined space, small difficulties can quickly deteriorate into serious problems. Confined spaces must be isolated before entry is permitted. Hazardous materials from other systems can be isolated by blocking the piping in accordance with recognised methods. The space which is to be entered must be brought to a zero energy level. This means locking out and tagging electrical switches. The same considerations apply if hydraulics or pneumatics make up part of the system. Any moving parts, though isolated from their power source, must also be physically restrained. And if the confined space itself can be moved, such as a tanker, it must be chocked properly. Radioactive emissions, though not common in our industry, require isolation procedures that follow strict government regulations. In many instances, it is advisable to barricade or rope off the confined space being worked on. This protects both those in the confined space and co-workers in the area from unwittingly placing each other at risk. Decontamination of a confined space of hazardous materials is best effected from the outside. Ideally, all such waste should be removed before entry. Unfortunately, this is not always possible. Contaminated materials can hide in sludge, in brickwork, in the joins of pipes, and many other places where limited access makes removal difficult. Entry into a confined space where contaminated material has not been completely removed is permitted only with appropriate personal protection and rescue equipment in place. Water-soluble contaminants are best purged from a confined space by flushing with water. Since increased temperature enhances solubility, the water is often boiled within the confined space. This flushing process should continue until the outlet is free of contaminated material. Direct steaming is best applied in cases where the dangerous materials do not mix with water. This procedure runs the risk of developing static electricity. Therefore, earthing of the system or the nozzle of the steam hose is required, particularly if the possibility of a flammable or explosive atmosphere exists. Toxic gases are removed from confined spaces by water displacement. This is followed by the introduction of uncontaminated air. Where flammable gases are involved, the purging should be carried out with an inert gas. The subsequent introduction of clean air will remove any final contaminants while ensuring that the atmosphere is not deficient in oxygen. In all these processes where the disposal of toxic materials is essential, local factory and environmental considerations must be taken into account. The atmosphere in a confined space must be tested before entry if there is any risk of toxic materials or explosive mixtures being present. It must also be determined that there is sufficient oxygen in the confined space. Accuracy in these atmospheric measurements is of vital importance. Therefore, the person conducting the tests must have specific training to ensure that the procedures are properly carried out. Results are recorded along with the time and signature of the tester. The atmosphere must be retested at least every 8 hours. If a particular situation warrants it, more frequent testing is necessary. Air-supplied respiratory devices are required when a toxic atmosphere or one deficient in oxygen are likely consequences of the job being performed in a confined space. The selection of this equipment must accord with local standards and the nature of the hazards to be confronted. The use of safety harnesses and guidelines have two main functions: to prevent falling and to assist in lifting an incapacitated individual during rescue operations. Again, selection of the harness should meet local industry standards and be guided by the nature of the work to be undertaken. Once all these factors have been taken into account, there remains one more step before entry into a confined space is permitted: signing the clearance certificate. Everyone, regardless of their position in the company or their job, must sign a clearance upon entering a confined space and sign off when exiting. When the work is finally completed, the individual in authority must personally inspect the interior of the confined space to make certain that no one remains inside and all equipment has been removed. Only then can he close off the clearance certificate and return the plant in question to service. Inherent in any confined space entry procedure is an associated program for emergency evacuation. The method of rescue will be determined by the nature of the confined space. All possible scenarios must be planned for and rescue and first aid procedures repeatedly practiced. The practice session should be done with a stopwatch. You'll be surprised at how long seemingly simple tasks can take when performed under pressure. These rehearsals should be acted out to the point where trained emergency medical personnel will be able to take over. In the heat of the moment, there is an instinctive urge for the rescuer to rush into a confined space to help a workmate who has become unconscious. More often than not, this simply leads to another unconscious victim who needs to be rescued. No rescue entry should be considered safe unless breathing apparatus is worn. To save lives, cool heads must prevail. Rescuers should be disciplined enough to follow procedures that were carefully developed when an emergency was not in progress. They must also be trained in first aid, including cardiopulmonary resuscitation. Awareness is the first vital step in preventing confined space accidents. Look around your workplace and determine what is in fact a confined space. It might not be too obvious at first glance. As you survey the potential hazards, the question you should keep asking yourself is, what if? Once a confined space has been defined, entry and working procedures must be devised which take all these what-ifs into account. There must also be an associated rescue plan which clearly details equipment, personnel training and emergency procedures. If these steps are taken and conscientiously followed, work in confined spaces need not pose unnecessary risks. What is true of all industrial safety is doubly true of safety in confined spaces. Think ahead, plan carefully, and work safely.